Hello, algebra students. We're going to look at exponent properties today, and this is actually the first section in chapter 5, which is monomials and polynomials. So let's get started. First, we have some definitions. Monomial just means it consists of one term. And so what is a term? Well, a term is a single number, single variable, or numbers and variables being multiplied together. So we have these examples. This is a polynomial, okay? Because there's three terms there, and anything more than one is called a polynomial. Um, but what are the terms? Okay, 8 is a term, and then 8x cubed is a term, and then x squared is another term. Okay, so this one has three terms, and the terms will be separated by plus or minus sign. Okay, so a monomial again would only have one term. So just a quick review we have here in the box. The exponent is written, just above and to the right of the base. Okay, so in this example, a is the base, b is the exponent. Okay, so multiplying monomials is the first thing we're looking at. And here's how you do it. If they each have an exponent, to multiply them, you add the exponents. So for example, something like x squared times x to the fifth, well, that equals x to the seventh. Okay, add the exponents. So we have these steps for multiplying terms because a term could also have a coefficient in front of it. So, or I should just say multiplying expressions, okay, whether or not they are terms in a polynomial or whatever. You multiply the coefficients and also add the exponents with like bases. So we'll just take a look at these examples and we'll see how that works out. The first one, it has no coefficients, right? So we just add the exponents of the variables with like bases. So we have m here has an exponent of 7, and we also have m with an exponent of 5. Okay, so that's m to the 5 plus 7, or m to the 12th. Okay, and n has an exponent of 3, and also there's another one with exponent of 2. So that's n to the 3 plus 2, or 5. Okay, add the exponents. Okay, so let's look at the next example. So this one does have coefficients. So step 1 says multiply the coefficients. So that's 5 times negative 2, so that's negative 10. And then add exponents with like bases. So we look at the numbers, the variables that where the base is the same. We have x squared, x, and we also have x here to the sixth. So we add those exponents. 2 plus 6 is 8. Okay, and then we look at y. Well, y is, this one is to the first power. Don't forget, it's like there's a 1 there. You don't have to write it down, but it's there. And the other y has a power of 3, so that's y to the 1 plus 3, which is 4. Okay, so Let's go on to the next operation, which is to raise to a power. So we have a to the m here, which is, a base raised to the power of m, but then we're raising that to the power n. And in that case, you simply multiply the m times the n. So, when we have an expression that has a coefficient with it, or a term with a coefficient, we use these two steps. Raise the coefficient to that exponent, and also multiply exponents with like bases. So let's look at that when we end up multiplying those exponents, what that looks like. So in this first one, there is no coefficient there, but we multiply the exponents. So we have this product of m cubed times n to the fourth raised to the power of 5. So we take the 3 times the 5, and you could think of it like this, okay? 3 times 5 is 15. Okay, oops. Let me erase my arrow there. Okay, and then when we look at n, we have n to the fourth, but that's raised to the fifth power, so that's n to the 4 times 5, so that's 20. Okay, so that's multiplying. And in this case, probably would help to leave this to also write the intermediate step. Okay, so this is m to the 3 times 5 power times n to the 4 times 5 power. So that's equal to m to the 15th times n to the 20th. Okay, so we look at the next example, and this is one that does have coefficients. So we have to raise that coefficient to that exponent. So we have in this first one, 2 is inside there, right? 2 is the coefficient in that expression, 2ab to the fourth. So we raise 2 to the third power. And then we have that a, which is also raised to the third power, and we have b raised to the 4 times 3 power. This time I will just go ahead and write that down as b to the 12th. Okay. Now we also have that times 5a cubed times b. So now what do we do next? Okay, now we're multiplying those together, and we have back here what we do to simplify those kinds of things. We multiply coefficients, and then we add the exponents with like bases. So the coefficients are 2 times 5, 2 and 5. So we multiply those to make 10, and we add the exponents with like bases. So a cubed, and we have another a cubed over here. Okay, so that's a to the 6th, right? Add 3 plus 3. And then with b, we have b to the 12th power. And b, again, remember this one that right here that I'm underlining, that has a power of 1. So 12 plus 1 is 13. So b to the 13th. So we have 10, a to the 6th, b to the 13th. I just going to erase those underlines. Okay, so Just checking my arithmetic there, exponent arithmetic. Okay. So next thing we're looking at is zero exponent. What do we do when the exponent is zero? Well, this is the rule. Any base, let's say a, raised to the 0 power is 1. So that's pretty simple. It doesn't matter what it is, it's 1. Doesn't matter what the base is. I mean, if you raise that base to 0, you get 1. So in this next example, we have a to the m power, a to the m. You raise that to the 0, it's 1. Okay? So we have these examples. What do we do with this? Well, we'll look at this first one. This a to the 0 is 1. So 2 times 1 times b squared. So we just that is just 2b squared. Okay? Okay, the next one, this entire quantity is raised to the 0 power. Well, anything raised to the 0 power is 1. See, we don't care what's in there. It could be as complex an expression as you want. If you're raising the whole thing to the 0 power, it's just 1. Now over here, in this first one, we didn't just have a result of 1 because the only thing raised to the 0 power was just the a. Right? A is raised to the 0 power, so that's 1. But it's still 2 times 1 times b squared, so that's why we still have that. Okay, and so the last example, we have 3a squared to the times b to the 0 power. So this b to the 0 power, that's 1. Okay, so that part is 3a squared. But the 4a squared b cubed is still there. And now we use the rules for multiplying these together. And remember, we're going to multiply coefficients. So 3 times 4 is 12. And then add the exponents with like bases. Here's those rules I'm talking about. Okay. Multiply coefficients, add exponents with like bases. So let's do that. So we did multiplied the coefficient, right? The 3 times the 4, that's the 12. And we look at our bases. We have a squared, and here we have a squared. So we add those exponents. So we have a to the 4th, and then we have b cubed. Okay, so really we just did the ordinary rules to multiply that we've learned, but when we see the b to the 0, that's just 1, so you can just sort of ignore it when multiplying. Okay, so we get 12a to the 4th b cubed. Okay, we have to learn how to deal with negative exponents, and this is by definition a to the power of negative m means 1 over a to the m power. And we will have those negative exponents come up sometimes when we divide monomials, which is the next rule that we'll look at. Dividing monomials, you subtract the exponents. Okay, so a to the m over a to the n is a to the power of m minus n. So when we're simplifying these, we will have these steps that are listed here. We're going to divide coefficients, and then we'll subtract exponents with like bases. okay, which is what we did just right here. So, look at these examples. First one, there are no coefficients. So we subtract exponents with like bases. So we look at x. Well, we have x, and I'll go ahead and write it x to the power of 3 minus 1. And that's because in the numerator we have the 3 as the exponent. In the denominator we have x, and it's to the first power, right? The 1 usually won't be written down, but that's the power of x in that case. And then we're going to do y. Well, y, we have 4 minus 2, right? So that equals x squared times y squared. Okay? So the next example is a little more involved. Divide the coefficients, right? This one does have coefficients. So we divide 20 divided by 10, and that's 2. Then we have a to what power? Well, 12 minus 10. So that is 2. And then we have c to what power? Well, that's 10 minus 7. So that's 3. And that's that one. Okay, look at the next one. So we divide the coefficients here. 36 divided by 6. That's 6. Now we subtract exponents with like bases. X cubed, there is no x in the denominator. So that just stays x cubed. Nothing to subtract. Y. Okay, we have y. Now here we have 2 minus 5. Okay, and so that is negative 3, right? So we'll write that like that. I told you we would have to deal with negative exponents, right? If you're going to subtract, there's going to be times when that exponent in the numerator will be larger. I'm sorry, when the exponent in the denominator will be larger, like this, where we have the 2 minus the 5. When that happens, we'll have a negative number. Okay. And then we have z. Well, z to the first, divided by z to the first, subtract exponents, that's 1 minus 1, right? That's z to the 0 power. Okay, so also notice, though, that when we're told to simplify these, it says no negative exponents in the answer. We don't want to leave our answer with negative exponents in these examples. So this last one, example C, is the first time that's come up where we do have a negative exponent here, right? So we don't want to leave it that way. Well, remember, scroll up here and look at it. There's what we do with negative exponents. A to the negative m equals 1 over a to the m. So y to the negative 3 in our example, that's going to equal 1 over y to the third. So we write that, and this time I'll go ahead and sort of write that out just to show exactly what's going on. I replaced y to the negative 3 with 1 over y to the third. And then the z to the 0, we can take care of that right now. That's 1, right? So we do not have to write down times 1. We know it's just 1, and we got it. So now we usually won't leave it like this. We'll write 6 times 6x cubed divided by y cubed. So you don't need to write down this intermediate step. You can go straight from this over here, to this. Because when you see that y to the negative 3 right there, well, that's just in the denominator, it's y cubed. Just put it down in the denominator and change it from negative 3 to positive 3 because that's what it is. Okay? And this time I went ahead and wrote down, this intermediate step because y to the negative 3 is 1 over y cubed, but we could just write it immediately just like that. Okay, erase all those notes and stuff. So that's the last of these properties and rules that we're going to look at today. So that's all for now.